Which air taxi will you hail at the vertiport? Is it too early to know? So many factors go into what makes the end product successful. Take a deeper dive here into 4 prominent eVTOL aircraft being designed for the air taxi business. Let's take a look at the future of flight, the future of advanced air mobility, with the eVTOL called Eve. Eve has its DNA in Embraer, and is being looked at very closely by Dubai for their urban air mobility solution. Obviously, Eve can be a solution for many countries around the globe once a regulatory framework is established, and certification has been met by the manufacturer. Dubai is a country that seems to be ahead of most others with the regulatory part. This is great, because somebody has to do it. Eve is showing for the first time, in this video, what their 4-passenger cabin looks like. With a full-size mock-up, it gives everyone a great opportunity to not just see, but feel, what it will be like flying inside this autonomous aircraft. Being able to board, and aboard, sit in the seats, try the seat belts out, and experience the dashboard in the cockpit as it is. Even though it may not have a pilot, there is still going to be an instrument panel that displays what's going on with the ride, with the weather, and with the aircraft itself. The quality of the interior, the seats, and the fabric go a long way to assure someone that they're going to have a smooth ride. This is the 5th generation of the cabin build, and they are very happy that they have had sustainability in mind with the materials they used in it. There's natural cork flooring for sound insulation. There are other natural materials used for the seats, like wool and cotton, and chromium-free leather. So, the aircraft has a wing and rotor design, with 8 fixed rotors for vertical lift, then there are 2 ducted fans at the rear, to push the aircraft forward on its wing lift. What they did was change the rotors from a rotating to a fixed rotor to simplify and remove moving joints. They're saying fundamentally, this design has been in the DNA of this aircraft from the beginning, and everything we've heard about previous configurations are still valid, but as part of the development process. They're analyzing all the variations of that same configuration, and they now believe they've reached a level of maturity that lets us compare the canard wing configuration with this wing and empanadas that still has 8 rotors. We're just witnessing a natural development process in the plan of this aircraft. The company feels they can have this ready to start commercial operations by around 2026, which isn't that far away. Eve says they have at least 1,900 confirmed orders for this aircraft, and more than 10 operators are ready to book this aircraft in their fleet. If you like this video, please hit the thumbs up button. I really appreciate it. And it lets YouTube know how you feel, so that the next Techzilla video will show up on your screen. I know you like tech stuff, so I made this next segment just for you. Let's take a look at the Lilium Jet. Arguably, the most innovative eVTOL in this lineup. This is a view from the rear looking forward of the jet and some storage in the cabin space, now of the 7-seater. The refinement of the 7-seater versus the 5-seater is an amazing transformation. It has lots of space for legroom and amazing views through the panoramic windows, giving this cabin a whole new feeling of comfort and safety. The concept of being in a large cabin and it being very open and airy is that it can give you a very good feeling. Another big key to the comfort in this cabin is a reduction in noise. The whole thing is built to give you a premium aesthetic. They say the main reason they chose ducted fans from the very beginning is noise. You will have none of the noise factors, none of the vibrations around you, and you'll have a much more pleasant ride. We're going to next hear Matthias Meiner, Chief Engineer, talk about the concepts and engineering of Lilium Jet's propulsion and wing structure, the very thing that sets this company apart from the rest in this field.
My name is Matthias Meiner. I'm one of the 4 co-founders of Lilium, and I met Daniel roughly 7 years ago when I was doing my PhD in robotics. He didn't really need to convince me to join Lilium because I was directly so excited about the opportunity of this technology and the vision behind it. So I'll walk you through a little bit how the flight controls and the flight physics behind this concept works. So we have 36 engines, and they're distributed into 12 flaps, 4 of which are in the front on the canard, 8 flaps on the main wing. The interesting thing about these flaps is that they're not just used for the vertical takeoff, so for the thrust generation, but they're also used throughout the whole flight envelope for all of the thrust vectoring that is needed to control every single axis of the aircraft. And the advantage of this is that since we need so much thrust for takeoff, this gives us exceptional control authority for all of the different flight phases. And we only have to control essentially the flap angle and the RPM of the engines. And that's all that the flight control system actually needs. So we don't have any rudders, any other aerodynamic surfaces like ailerons, and that obviously makes it much more simple and also much more efficient. For vertical takeoff, you can imagine these flaps are all pointed downward in a vertical position. And then after around 10 seconds of hover flight, where we generate the first initial altitude, they are slowly transitioning into a more horizontal position, thus accelerating the aircraft. And then in cruise flight, all of the aerodynamic lift is purely generated by the wings and by the main body. Since we have 12 flaps, we also have a very highly redundant system. That means in case of failures, and that is actually something we've already seen in flight test, the flight control system directly recognizes that and redistributes the thrust in a way that below a second, the aircraft is stabilized again. This just shows that this distributed nature is not just adding a lot of control authority, but it's also adding a lot of safety.
Amazing! This is the technology that will be in the future. Please subscribe and like for more Techzilla videos. This video examines Joby Aviation's S4, a top eVTOL airplane, and its amazing engineering. Joby Aviation's February 2021 videos of an operational S4 prototype garnered attention. This is important, because only a few of the more than 100 companies working on eVTOL aircraft have prototypes that are fully functional. After 10 years of work, one of the most notable things about the plane was that it was quiet when hovering, which is the noisiest part of the flight. Joby Aviation CEO Joe Ben Bavard showed this in a video as he stood in front of the running machine to give a speech. We can examine Joby Aviation S4's unique and durable design. Propellers distinguish the plane. Unlike Joby's S2, the S4 has 6 high-solidity propellers that appear small but are actually 2.9 meters in diameter. Anhedral tips improve hovering and reduce noise on the S4's 5-bladed propellers. This is crucial for eVTOL developers who struggle to reduce noise and cannot use anhedral propellers and variable pitch blades. Comparatively, the Robinson R rotor tip speed is 215 meters per second, while the S4's is 113. This lowers noise to what would be described as tree wind. The Joby S4's inboard propellers tilt the blade without tilting the nacelle. Each propeller has two 70-kilowatt motors for redundancy. eVTOL aircraft cannot tilt inboard propellers without tilting the wing. Joby Aviation's push-link fixed this. The VTOL has 2 tilting rotors. Few small aerobatic drones, including the Hyundai SA1, have VTOL rotor airframes. The S4's forward-swept wings are also a striking feature. Kitty Hawk Heaviside and eVTOL aircraft forward-swept wings are intriguing. The plane's center of thrust and center of balance may not be able to cause torque if the wings are set up this way. The CEO says the S4 lift-to-drag ratio is 16:18. The S4 can only lift off at a weight of 1,815 kilograms because it has tricycle landing gear and a composite fuselage. With a maximum takeoff weight of 2,177 kilograms and a payload of 454 kilograms, S4 V2 will meet the FAA requirement of 91 kilograms or 200 pounds per assumed weight per seat. The S4 V2 battery pack is the biggest engineering challenge per specifications. 150 miles and 200 miles per hour require a 200 kilowatt-hour battery pack for the S4. Joby claims an unprecedented 235 watt-hours per kilogram pack energy density. Despite high pack energy density, the battery and cooling system may have been integrated into the aircraft airframe and are difficult to remove. S4s use 170 watts a kilogram. Get more info on Joby from the link in the description. This next eVTOL looks good for the Airtaxi business also. Check it out. The CEO of Wisk in 2010 says we wanted to skip traffic, get to our destination faster, and be responsible to the world, our employees, and the communities we serve. That inspired a mission to make everyday flight safe for everyone. We've developed self-flying all-electric vertical takeoff and landing aircraft for 12 years. Airtaxis with the largest fleet. Flying a fixed-wing aircraft, test the vertical takeoff and landing like a helicopter. Pioneering commercial technology. We design, test, and modify airplanes. We're lucky aviation leaders care. Boeing and Kitty Hawk investors and partners are special. After 12 years, we discuss our 6th-generation aircraft. Our industry-leading team, investor dedication, and technology innovation created the first self-flying all-electric 4-passenger vertical takeoff and landing air taxi. Gen 6 prioritizes safety. Generation 6 exceeds commercial aviation safety standards. Our 4-core generation, Gen 6 uses 5 generations of design and testing experience to improve performance and safety. Our 6th generation aircraft can fly 120 knots at 2,500 to 4,000 feet, for 90 kilometers, with reserves. Fewer parts, hydraulics, and oil mean fewer component failures and a stronger system. These changes improve safety, stability, comfort, and noise. The greatest change is the larger cabin with for seats and baggage and carry-on storage like commercial flights. Generation 6 air taxis will be the most adaptable. Safety, performance, and configuration were examined. Passengers have great visibility, space, and storage. Wi-Fi, gadget charging, and comfortable seats let travelers work, rest, or enjoy the scenery. Generation 6 should serve all. A price that lets college students and business people utilize it daily. From simple interfaces to easy access. We design for varied passengers. We're one of few companies developing self-flying airplanes. Advanced air mobility, scales, and benefits from autonomy. Aviation's long history of autonomy, rules, and traditions can inspire new ideas. Computers perform 92% of commercial airplane pilot duties. We are building an autonomous airplane using that technology and patented self-flying software. Our ground control station monitors many planes while the aircraft and its autonomous systems handle most situations. This removes humans from the cockpit without eliminating them. As humans are still part of the system, autonomy's value proposition is to take in all this data, analyze it, identify hazards, and navigate a safe, predictable, dependable path every time. The Gen 6 plane's life-changing potential is exciting. Imagine seeing new places, driving home without traffic, and attending that soccer game you wanted to. That buys time. Wisk is dedicated to testing new ideas to create a safer, cleaner, cheaper, and more responsible way to get you to your destination faster and autonomously. We hope you enjoyed this video. Please subscribe to the channel and smash that like button to get more videos like this.